Hey guys, welcome to lesson 116. Oh my goodness, this lesson is so much fun. I don't know if you believe me, but anyway, I only kind of like this lesson. Most of the time when we get to a probability lesson, it's usually at the end of the book, just like we're at right now. And maybe it's the end of the year a lot of times and we say, no, you don't need probability, okay? But we are here and we are going to do this, okay? Probability is actually kind of fun, to be honest with you, but it's a little bit like a mind game, okay? So most students take it one of two ways, like, oh, cool, that's pretty easy, or no, Miss Jessica, don't keep talking, it's going to hurt my brain, I don't understand what you're talking about, okay? So you have to decide which way you're going with it. Por favor, pick the first one. Oh, wow, that's really cool. That's not as hard as you made it sound, okay? That's how we want to approach the situation. Okay, so what we're doing is we're deciding the probability or sometimes the possible ways that you can arrange something. Like for instance, let's say that you have the letters A, B, and C. And you want to know how many different ways could you arrange A, B, and C. Well, I could easily tell you, like the book says, you could do A, B, C, that's one way. You could do A, C, B, that's another way. Then you could put B in front, you could do B, A, C. You could do B, C, A. Or you could put C in front and do C, A, B. Or C, B, A, right? So then you count 1, 2, 3, 4, 5, 6 different ways. Well, is that what I'm trying to have you do? Is that you actually have to figure it out each time? No, there's math involved, okay? They're called permutations. It says we call each different arrangement of the members of a set in a different order a permutation. So there are 6 permutations of the letters A, B, and C. But there's an easier way to find that. What you do is, look, you have 1, 2, 3 options. So you make a box of 1, 2, 3. How many options do you have for the first box? 3 options, because it can either be A, B, or C, right? Okay, but how many options do you have for the second one? Because if you already used A, B, or C here, then you only have 2 more options left here. Do you agree? Because watch. If I put A here, now I either have to put a B or a C here. We know that. There's only 2 options for the second box. Okay, well once we get to the third box, how many options do we have left? Only 1. Porque mire, if I had A here and C here, we all know what's going to go here. Our only option left, which is B. Okay, so we have 1. And then what do? You multiply. 3 times 2 is 6, 6 times 1 is 6 again. There are 6 different ways to put A, B, and C in order. Okay? But oh my goodness, what if I told you that you could repeat? That I didn't even care if you did A, or A, B, B, or A, B. I didn't care that you repeated all of these letters. Well, puchica, Miss Jessica, there's no way we're going to make a list that long knowing all of that, right? Okay, so how would you do it if you could repeat? How many options would you have for the first box? 3. You could either put an A, B, or a C. How many options would you have for the second box? 3, because you could still put an A, B, or C. And how many options would you have for the third box? 3, because you would still be able to put A, B, or C. So then how many different ways could you do that one? 27. And I could tell you that you don't want to be writing 27 different options here to figure that out, right? So let's use that math right there, which by the way is called the fundamental counting principle, what we just did right there, to do our examples 1 through 5 before we get into more, well actually when we get into probability, okay? So here we go. Look at example 1. How many different ways can the numbers 3, 5, 7, and 8 be arranged if no repetition is permitted? Okay, so we're arranging these. We have 4 boxes because there's 4 numbers. How many options do we have for the first box? 4, because it can either be this, or this. But then once we use one, how many options do we have here? 3, So how many options do we have here? 2, and then we only have one option left because there's no repetition allowed. 4 times 3 is 12, times 2 is 24. There are 24 different ways to do that one, okay? Look at example 2. How many 4-letter signs, so we don't know the letters, but we do know that there's 4 letter signs can be made from the letters equal, E, Q, U, A, L, if repetition is permitted, okay? Don't be confused about this. There's 5 letters here, but only 4 choices because what did they just tell us? It has to be a 4-letter sign, okay? So 4 boxes. Well, how many options are in the first box? 5. You can either have the E, the Q, the U, the A, or the L. There's 5. And by the way, repetition is allowed. So what happens in the second box? You still have 5. Because you can use the E, the Q, the U, the A, and the L again. And in the next box, and in the next box, because repetition is allowed. And when you multiply 5 times 5 times 5 times 5, you're going to get 625. Different ways that you can use the word equal to form 4-letter signs. Okay? What about example 3? Example 3 says a multiple choice quiz has 8 questions, and there are 4 possible answers to each question, okay? Let's just, to visualize it, let's just like act like these are our options, A, B, C, and D, okay? A, B, C, and D, there are 8 questions. How many permutations of the answer are possible? Well, question number 1, how many options do you have? 4. Question number 2, how many options do you have? 4. No one said that you can use the A, B, and the C 50 bazillion times, right? So every time you're going to have 4 options. This is why you have to study. Because guess how many different ways these can be arranged? Guess how many different ways your test can have answers? 4 to the 8th power is 65,536. So if you think that you're not going to study for an 8-question test because you're just going to guess all the answers, well, there are 65,536 different ways that that test can be created. So hopefully you're not trying to guess too much, okay? Look at example 4. How many 3-letter signs, so that means that we know that we have to make a 3-letter sign, can be made from the letters numeral? How many letters are that? 1, 2, 3, 4, 5, 6, 7. If no repetition is permitted. Okay, no repetition is permitted. So after we use one of the 7 for the first one, we only have how many choices left for the second one? 6, because let's say that we use the M first. That's not a choice anymore because we can't repeat it. So now we use the R. So how many do we have left for this one? Only 5. 7, 6, 5. And then you multiply it. 42 times 5 is going to give you 210. Turtle. Okay, that's how many different choices. And look at 116.5. Jamie had 5 places to put items in her display. 5. 1, 2, 3, 4, 5. She had 38 different items. How many arrangements were possible? Okay, well think about it. 38 different items. Obviously, she can't repeat an item because she doesn't have more than one of those items. She has 38 different items. So you're going to start out with 38 choices, but then you're always going to go down by 1 after you use one of the choices. And oh my stars, what a huge number. 38 times 37 times 36 times 35 times 34 is going to give you 60,233,040 ways that she could arrange those items. Whoa. Okay? And now we're going to get into the real probability. Okay guys, what you have to understand about probability is that probability has an equation. The chosen outcome over the possible outcomes. Okay, the chosen outcome over the possible outcome. Like for instance, if you have like a centavo and you throw the centavo up in the air, a lot of times they're going to ask you, is it going to land on heads or is it going to land on tails? Heads is the one that has the head of the person there, and tails is the opposite end, okay? Well, let's say, what's the probability that it's going to land on heads? Well, the possible outcomes are 2, right? Because either it's going to land on heads or it's going to land on tails. But the one that you want, there's only one chosen outcome. You want heads. So your probability of getting heads is 1/2, 50% probability, because either it can land on heads or it can land on tails, okay? That is where probability starts. That's the basics of it. The number of possible outcomes from the chosen outcome, okay? So let's look at example 6, because you're in Algebra 2, so it's not going to be as easy as heads or tails. It says 2 dice are rolled. What is the probability of getting a 7? Okay, 2 dice are rolled. Those are those, what are they called? Dados, I think, or I don't know. I'm not sure what they're called. But those little things that have the little numbers all around them. Okay, look at the box right here. Look at the box right here. This box is very helpful because it's telling you, look, you have 2 of them that you're going to roll. So here's all the possible outcomes of how they're going to come out to make 2, to make 3, to make 7, etc. Okay, so they already did that work for you. There are 36 possible outcomes in that chart. That chart is going to be very helpful for you anytime you do your homework, okay? Because you're going to flip over to that chart and you're going to count it yourself. Now count, how many ways can you get 7? It shows you right here, a 6 and a 1 will give you 7, a 5 and a 2 will give you 7, a 4 and a 3 will give you 7, a 3 and a 4 will give you 7, 2 and a 5 will give you 7, or a 1 and a 6 will give you 7, okay? When the 2 dice are rolled. So look at it, let's count. How many 7s do you see there? 1, 2, 3, 4, 5, 6. I see 6 7s. So there are 6 possible ways we're going to get the chosen outcome. And then we reduce to 1/6. 1 out of 6 1 out of 6 chances that you will roll a 7 when you roll that die. Okay? That's how you do example 6. But look at letter B. What's the probability of getting a number greater than 8? So again, we have 36 possible choices, and you might want to write that on the side of it. 36 possible, because then you'll remember every time that you have a problem like this, you'll go back to it and know that there's 36 for the bottom. Now count how many numbers are there that are greater than 8. So that's all the 9s, all the 10s, all the 11s, and the 12. There are 1, 2, 3, 4 9s, 5, 6, 7 for 10, 8, 9, 10 numbers greater than 8. So it's 10 over 36, which means we're going to divide that by 2, 5 over 18. 5 and 18 chances that you're going to roll a number greater than 8. Okay? But now look at number 7. Here's something what's called independent events. Independent events. Look at it. A fair coin is tossed. That's what I was telling you about, the centavo that has the head or the tails. 3 times. What is the probability that it's going to come up heads every time? Well, here's the thing, you guys. They're independent events. That means, like, look, if I throw the die, the centavo 1 time, you have a 1 in 2 chance of it being heads, right? If I throw it a second time, is that going to give you more probability that it's going to be heads? No, it's an independent event. Whatever happens on the second time happens on the second time. It has nothing to do with the first time, right? So I have to put it again, 1 over 2. And then the third time, 1 over 2. I have 3 independent events here. So what's the probability that every time it's going to be heads? You have to multiply 1/2 times 1/2 times 1/2, which is 1/8. You only have 1 in 8 chances that every time it will come up as heads. If you only roll it 1 time, you have a 1 in a 2 chance. But if you throw it 3 times, you only have 1 in an 8 chance, because they're independent events that need to be multiplied together. Okay, so let's look at the next one though. A fair coin is tossed 4 times and it comes up heads each time. what is the probability it will come up heads on the next toss? Careful of that one. That's way different than this one, you guys. This one wanted to know what is the probability that every time it's going to be heads. Now this time, they've already thrown it 4 times, it came up as heads, and they want to know what's going to happen on the next one. Well, that next one has absolutely nothing to do with the other ones. It is a probability of only one time, one independent event. So what's going to be the probability of that one independent event? 1 over 2 still, 1 over 2. There's no multiplying on that one on example 8 because they're not asking you what's the probability of it happening 5 times or happening 4 times. They're asking you the probability of what's it going to happen on the next time, which is only one time. One independent event, so it's only 1/2. Okay? So go ahead and try to do A and B. I can understand that you might feel a little bit like, Miss Jessica, I just prefer you to do it with me because I'm not really sure. But I would prefer you to exercise your brain a little bit, to be confident in what you just heard, see if you can apply it by yourself, and if not, I'm here to explain why it is that way or not that way. Okay, so go ahead and try the practice, and then we'll come back and check it. Okay, on B, they're a little bit of bullies because they combined 2 concepts, which was a little mean, but anyway. Look at letter A. There are 3 chairs in a row, so I put 1, 2, 3. There are 7 students. How many ways can these students sit in the 3 chairs? Okay, there's 7 students. You can't repeat students because there's only one of you, okay? So you have 7 for the first one, 6 for the next one, 5 for the next one for your choices. So there's 210 choices. Now here they're combining independent events and the rolling of the dice. Roger rolls a pair of dice twice. What is the probability in 2 rolls that he will get, so that's 2 independent events, that he will get a total of 7 on the first roll? Well, we look over at our table, there's 6 chances for 7, so 6 over 36, times, because they want to know what it is on the second roll. Okay, together, those are 2 independent events together. Total greater than 9. Well, there's 6 that are total greater than 9 because there was like 3 10s, 2 11s, and 1 12. So again, it's 6 over 36. So I reduce down to 1 over 6 times 1 over 6 equals 1 over 36. The probability of that happening in that order like that. Okay, if you have any questions, just let me know. You could also, if you're feeling very shaky, what you could do is find the probability problems in this lesson. Do those first, send me a picture, tell me to check it for you, because that's going to be number 11 and number 12 today. I'm not seeing any more, but I could just be blind for a second. Okay? Bye, guys.